So this will be a recap of what we did in class this week of dealing with propagating uncertainty and fleshing out the spreadsheet. So focus on propagating the uncertainty, because getting that in the spreadsheet is a little tricky, but we'll go through the other parts of setting up the graphs and so forth. So in class, each person had a simple syringe of a particular volume in milliliters, and I'm just going to make up some numbers here. So I'm going to say I have a 100 milliliter syringe, and I'm going to say that when I'm positioning the plunger on the syringe, I look at it and I think I could probably get it to within 1 milliliter based on the markings. Then in the class, people measured uncertainties. Measured lengths, and I'm going to make up some lengths here. Not very precise measurements, but kind of get a little bit of a spread of the data. So I'll go with 6 people making their measurements of length. And for the class estimate of the length, we'll go with the mean of the length, which is in centimeters. And then we'll also have the uncertainty of the mean of the length, which will also be in centimeters. So to get the mean, type equals average. And then drag over the cells that we want, close parentheses, hit enter. For the uncertainty of the mean, we will use a standard deviation. Again, drag over the cells, close parentheses. Okay, so the standard deviation is the uncertainty of the mean. Over here, we will put the time, so we'll say that the same people pushed the syringe with different rates, different times, and I'm just going to assume times 1, 2, 3, 4, 5, 6. So some people were fast, some people were slow. We also need the uncertainty of the time. So if you were using a typical phone app, your uncertainty, you could say, is 0.01. Then the speed, which is in centimeters per second, is the length, the distance, divided by the time. Now in this situation, everyone used the same length, which was the mean length, which was over here in cell A11. And then we add the uncertainty, which is in cell A12. And then we divide by, I'm sorry, I got ahead of myself. We're just taking a distance over time here. A11 divided by the time in E5. Now, when I'm doing this, I'm going to fix it, but if I copy it down, I want to show you what happens. And that is, if I copy this down, it changes so that it's not referring to A11 anymore. So that's where we use the dollar signs. We want to make it always refer to A11. So at the very least, we need a dollar sign in front of the 11. If we put a dollar sign in front of the A also, that will make sure it always goes to that cell. So now if I copy this down, all of them are calculated correctly. Keep C length pointing to the same place, and then divides by the time for that row. I'll show you a different way of doing this in a minute. Okay, so we want the uncertainty of the speed. Which means we need the max speed, and we need the min speed. So to get the max speed, I want to take the maximum length, because that's in the numerator, so higher speed for larger length, so the max length is going to be in this cell A11. $sign A, $sign 11. I want to add the uncertainty, which is in cell A12. $sign A, $sign 12. Close parentheses. Make sure you close parentheses. It's very important that you can use parentheses so that it knows exactly what the numerator is and what the denominator is. Slash for divide by, and we have to divide by the smallest time, which would be the time over in column E minus the uncertainty over in column F. And here I don't want the dollar signs, because as I go row to row, I want to get the data from that particular row. Okay, so I can copy that down. That would calculate the maximum. Maximum speed consistent with the data in here. Again, it keeps pointing to the length and its uncertainty, but divides by the time for each row. For the min, I'll set it up a slightly different way if you prefer this. Instead of trying to always refer to cell A11, I'll just type in the number 8.217 minus, I want the minimum speed, so I want the smallest length consistent, which is 0.069. I'm keeping too many digits here, but and then divide by the time, so parentheses, the time. Now I want the maximum time, so I add the uncertainty. Okay, so the max speed was the length plus its uncertainty to give me the largest distance consistent with the uncertainty. The max speed you divide by the minimum time consistent, which is the time minus the uncertainty. For the minimum, you flip the plus and minus signs around. We want the smallest consistent length on top and the biggest consistent time on the bottom. Then for the uncertainty of speed, we will take the average, not the average, half of the separation between the two. As you can see, that our best speed is kind of in the middle here, so we want to go half of the distance between these two to get the plus and the minus. So it equals 1/2, 0.5 times, and then I want to add the max minus the min. 1/2 the separation between max and min, and that's my uncertainty. Okay, my rate of volume flow. And I'm just going to do a whole big thing up here and group these cells together, because all of these cells are going to deal with. So these are, I merged these cells in here. I can just type volume flow rate, which is in milliliters per second. So the best value is going to be the volume 100. I need the equal sign, equals 100 divided by the time. So that's the flow rate for the first line of data. Copy down. get the flow rate for the others. Now I want the max, and the min, and the uncertainty. The max, I want the max volume that's consistent. So it could have been as much as 101. Divided by the minimum time, so the time minus the uncertainty. For the minimum, the volume flow could have been as low as 99 milliliters a second. I divide by that, divide by the time, plus the uncertainty of the time. That up. Okay, let's do some things here. Andrew, no, I know. Undo, undo. Okay, somehow I ended up typing in here when I didn't want to be, so I'm just going to fix that data point. And the problem was when I was doing that, I did not put the equal sign here, so it didn't know that I was clicking on a cell to put it into a formula. So 99 divided by the time plus the uncertainty of the time. And the uncertainty is going to be the max. Oops, forgot the equal sign again. Equals max minus the min divided by 2. And then I can just copy these three things down. Okay, so when it comes to making the graph, I want speed. And I can go over here and hold down the control key and select over my volume flow rates, over to insert, charts. Always pick a scatter plot. We don't want to connect the lines. But those look pretty good. And I tried to pick the column heading so it would plot those, but apparently it just took one of them and made it the title, so we will make a better title here. Emptying a syringe. And then remember, you also need to add things like over here, add chart element, the axis titles, so the horizontal title was the speed. Centimeters per second. And chart design, add element, add the vertical. This is volume flow rate. Milliliters per second. And you could add the other elements. So we want to add the uncertainty bars. So click on chart design, add chart element, error bars. We do not want to choose any of these, so we go to more options. And it looks like it just automatically picked a bunch of horizontal error bars. It just picked something that doesn't make sense. Okay, and we'll fix those in a minute, but right now I'm in the vertical error bar menu. We want to specify custom values for vertical error bars, specify the values. And our vertical error bars, the error bars in the volume flow rate, are in this column here in column O. So if you click on this little arrow, it lets you select the numbers, and then click there again. You can go to the negative error value, click on that, you want it to be the same. Click again here, and click on OK. And you see some really teeny volume rate error bars. For some reason, it just, whenever you do error bars, it just throws in horizontal error bars at plus or minus 1. So right click on one of these horizontal error bars, format, custom, specify value. So again, for the horizontal error bars, we want the uncertainty of the speed. We want to do that both for vertical, both for one side and to the other side. And for some reason it added a 1 here because it's just really weird. So I'm getting rid of everything I don't want. These two should look the same. There it is with my error bars. Adding a trend line. Right, one easy way, right click on one of the data points, add trend line. We want to do linear, display equation, display r squared, and there it is. And you can move it someplace where you can see it. And it's saying the intercept is 5 times 10 to the minus 14, which is actually, I mean, that's 0. That's just rounding error. And the last thing we did was to get uncertainty of the slope and intercept. I'm going to pick a whole bunch of cells here just to show you what happens and what you can ignore. You type equals, L-I-N-E-S-T, open parentheses, and it says first you want the known y's, which are the verticals, which is the flow rate, comma, then it wants the x, or the horizontal, so I want the speeds, comma, 1, comma, 1. Close parentheses, and then hold down Control, hold down Shift, and hit Enter. And as some people saw in class on Google Sheets, apparently this is automatic. It gives you way more numbers than we need. But we just care about these top 4 numbers. Top left is slope. Next one is the uncertainty of the slope. And the others we don't care about. Over on the right, the first one is the intercept. And the next one is the uncertainty of the intercept. We don't care about those. The units. Excel does not understand units, so as we talked about in class, you have to figure out the units for yourself. Okay, here I've copied the sheet, but I've arranged the data differently. Here we're assuming each person measured their own length and uncertainty, and their own volume and their own uncertainty of volume, or maybe the same person did 6 trials of the experiment. I want to show you what will change. Over here for the speed, I should have got rid of this because we're no longer averaging the class data, so all of that went awry. But here the speed, instead of the class length, we want the individual length, which is over here in cell A5. So we'll type A5 here. You don't want the dollar signs because you want each person's data to contribute. Okay, so different people measure the length slightly differently, or you measure the length slightly differently several times each time you push the syringe. By the same token, maximum, we need to use your length, which in this scenario is A5. And we need to add your uncertainty of length, which I have stored in cell B5. Some people had better lengths, better uncertainties. Some people had others, depending on how well you thought you could do it. The time is still the same. You still have individual times. That has changed how I calculate the max. The min. Here I just need to redo what's in the numerator here and refer to the actual cell. So I want the length of your measurement minus the uncertainty of your measurement. And again, the times stay the same. The uncertainty and the speeds are still the same. We take the half of the difference between the max and the min. Just now we're treating it trial by trial instead of using average class data for the length. For the flow rate, again, it's well, everybody still has 100, so I'll leave that the same. Yeah, let's change it. Let's be right. So the number is C5. So these aren't going to change because everybody was using or you use the same syringe several times. The max is going to change again. Instead of typing in 101, I'm going to type in the formula because now it appears different people had different uncertainties. So we'll take C5 plus D5. I messed something up. And what I messed up was, I'm not sure. There's something there that doesn't belong there. So I want C5 plus D5. So I think I fixed it. Copy that down to everybody, or all of your trials. So it's making small differences, but not big differences. And again here, instead of 99, I'm going to type your volume, which is in C5, minus your uncertainty. So this will be the smallest volume consistent with your data. Okay, so if in fact, instead of averaging the class lengths, we could have done it this way. If each person was recording their own length and their own uncertainty for everything, or if you did it 6 different times, and each time remeasured the length and redetermined how well you thought you were able to set the volume. I will also put this spreadsheet on Canvas with both tabs for you to look at. Actually, I'm not sure what happened here. Okay, it's back here. The other one is back here. So there's the first way. There's the second way. Very well. Get in touch with me if you have more questions.